Thank you, Olaf, for this kind introduction. When I started 20 years ago to build PDF tools, I didn't care about rendering. I started like every other company that takes care of PDF tools with the basics functions such as creating PDFs, reading PDFs, merging and splitting, and all those functions. Then later, 10 years ago, I decided that we need rendering because many processes in PDF processing workflows need a rendering engine. So I discovered quickly that PDF has a very unique graphics model, and most libraries that I know that are publicly available, and even graphics processors that are driven by the gaming industry have a very different graphics model. And if you try, that was my first approach. I tried just to map the PDF constructs that I read in a PDF reader library to a graphics processor, and then I was astonished that the result was not the same. So I want to give you some examples. I built my presentation around the story. Imagine that you are in the same position as I were 10 years ago. You decide to create products that have a rendering engine in it. So first you ask, what is a rendering engine? What is it good for? And what applications can I do with that engine? Then you go to your development department and tell them, I need a rendering engine, so please implement one for me. It's of strategic importance, so we have to have our own rendering engine. Then the programmer will take care of the topic and see what he can do, and probably he will take the approach to use a graphics library or a graphics engine to render the PDF, and he encounters some obvious and less obvious problems with that. Then he's consulting the PDF specification, and in the specification he reads how to render PDF, and he finds out that there are some differences between what Acrobat does and what's in the specifications, and I will get to that point too. And of course, there are lots and lots of rendering topics that I can't cover here because I would run out of time, of course. And I give you a brief list of details that I didn't cover here. And at the end, I will revisit that question: how can I implement my own engine after I've shown you the examples? Here's the manager's view in my story. Either you write some tools, such as a PDF to raster image converter. That's the most obvious tool that needs a rendering engine. Then you have viewers, embedded viewers, that many embedded viewers that you know that are embedded in document management systems, for example, multi-format or multi-purpose viewers. They have some kind of rendering engine in it. And PDF printers, even a transparency flattener. You learned today that a transparency flattener does transparency flattening in most cases by just rasterizing parts of the PDF content and re-embed it into the resulting file. Not so obvious applications are, for example, PDF to other document format converters, such as PDF A2 to PDF A1, need some transparency flattening in it, or to other file formats that don't have such elaborate transparency model, for example, such as OOXML, etc. They need some parts of the content to be rendered. Other applications are archiving, quality assurance in print workflows, multi-channel output management, just to name a few. Here is a concrete example. You have a print workflow, you print a PDF in a print workflow, then you have a camera that photographs the result. You get an image, you have a second rendering engine. The first one is part of the raster image processor of the printing engine, of course. Then you have to take another rendering engine that does it differently, maybe, and compare the images, and you get something like this. And you see the left image is slightly different to the right, and the image compare tools gives you all the places where the images differ in red color, for example. That's a typical application from the management's point of view. And now from the developer's point of view, if he gets the order to develop a rendering engine, he thinks of something like this. You don't need to understand the code here. It's just you just need to read the commands. There are basically 4 parts. You have a few calls to get the PDF page, a call to create the output image, then call the renderer, which transforms the PDF page into an image. Then you have to store the result. And the third part, that's the piece that the developer has to develop. That's, from his point of view, the rendering engine. Now he is asking himself the question, how can I get to an implementation as fast as possible? And usually you go the way that you look around what's on the market. For example, if you develop that engine on a Windows platform, you will probably use a Windows Presentation Foundation as a graphics engine. If you write printer driver version 3, you probably would use GDI. If you are on a Unix system, then you probably would use OpenGL and the like. If you use a library that you can't change, then you think you already know that the library cannot map all PDF structures to OpenGL calls, for example. So you try to pre and post process the graphics objects. For example, typical example is OpenGL only handles RGB images, so you convert the source images first to RGB if it's CMYK, then you send it to the graphics pipeline, and then you get the result, which is RGB as well, and then you probably convert it to CMYK if you need it in this color space. And all missing functions that you don't see in that library, you build them around. Another approach could be you adapt an open source graphics library such as Cairo Graphics, which you can get in the source code, the code edition. Then you try to add the missing functions. You think that you probably must change some things, but you don't know exactly. Maybe you must change the vector pipeline or the rasterizer. You don't really know what you have to change here. Or you write it from scratch, then you're sure that the things are done the right way. But you don't know how elaborate this is. You don't know how much effort you need and what the risks are and the cost. And to answer all these questions, I have prepared a number of examples. Let's start with a little quiz. I have put some code here, PDF content code. Who knows what the result of this is? Leonard, sure, you sure know.
It's a one unit wide line.
Yes, it's a single pixel, that's correct. That's the appearance of this code. Next. Okay. Who knows that one?
It's like a diagonal line.
It's a horizontal line, yeah, correct. This one? That's just the same. It's just an alternative way to draw a horizontal line. Then, a bit more complicated for those who don't know the operators by heart. 10W means line with 10, 1J means round cap. And then you construct a path of 0 length and then stroke it. What's the result of this? Who knows?
Should be the cat.
Olaf is right, it's a circle. Who told you that you must use Bezier curves, cubic Bezier curves, do a lot of math to draw a circle? Here's the code to draw a circle. Then, next example. If you just change the cap style from round to square, that's a possible result. But is that result correct? You can't tell because if it's a 0 length line and you don't know the direction of the line, so this is not sure whether the rectangle is the right thing to do here. You could rotate it by 45 degrees and it would be correct as well. And here's an example where it matters. If you have a dashed line and the dashes are 0 length, then you could do it the way on the left side or you could do it the way on the right side. Theoretically, both presentations are correct when you go after the spec, but the expected result is on the left side, and that's what Acrobat does. And on the right side, that's what a graphics processor does in the best case. I have to go back. Now, you run all these examples through OpenGL. What happens? Who knows? Nothing appears. You don't have any appearance because OpenGL does not display things that have either 0 length lines or 0 area shapes. In the worst case, the graphics library will crash, such as GDI+. I was mean and I created a PDF file with rotated 0 area lines. The expected result is the above line, and that's what Acrobat does. It's correct. And the line below is if I test rendering engines that are on the market, you see all lines that are not vertical or horizontal are gone. Why is this? This has something to do with anti-aliasing. How does anti-aliasing work? Anti-aliasing uses the property that that the pixel is not just 1 or 0. You have a grayscale of at least 200 different levels, so you can reduce the effect of this of the line drawing edges that you see, the shaggy edge you see there if you draw lines that are not pure vertical or pure horizontal. And this is done by, in most renders, done by computing the area a pixel is covered. If you see the black square on the left topmost edge, you see that the coverage is 25%. So you use a level of 25% to display that pixel, and the coverage of other pixels are 50 or even 100%, so you get a real image that is on the right side, when you map that figure to the image raster. But now, if you have a zero shape line, how much coverage do you have with a pixel? The coverage is 0%, so you won't see it. That's the reason why these lines disappear. That's the main reason. And all graphics processors and all graphics library that I know work this way, but not a PDF rendering engine. So, to wrap it up, PDF has special so-called scan conversion rules that describes how to handle disappearing or how to handle zero shape area shapes in general, and how to handle degenerated paths such as zero length lines which need to be stroked. You could, if you use a commercial library, you could try to pre-process the paths and do something with them so they appear as expected, but this is not the real solution. The real solution is that the rendering engine must handle such cases. Then, let's cover another topic. Color transform. Your current page might be CMYK and your source image might be RGB. Your graphics processor only supports RGB, for example. Then you render in RGB and convert the current page to CMYK afterwards. But while it might seem to be correct, it's not. Because if you use, for example, transparency, it matters whether the target surface is in CMYK or is in the RGB space. On the left side, you see all the blend modes that exist in PDF, and then you see the visual result that is correct on the left side. And if you do the same with exactly the same input on an RGB surface, you see how the colors move. And that's why it matters how you render, how your graphics engine renders colors on the target surface, and how in which color space transparency calculations are performed. Here again, how most graphics processor works. You have the PDF file, you have process colors such as RGB or CMYK, or have a number of spot colors. As I learned today, for example, the Coca-Cola color is a typical spot color, and you convert them to RGB, then you do the blending, and then you do the color conversion to the target device. That's wrong for most PDF files. Another topic is overprint. With graphics libraries, they don't support a thing like overprint, and you cannot solve that problem using pre- and post-processing either. Because in order to implement overprinting, you need to separate all colors on the target surface. You have the process color and the spot colors, and you do all the rendering for the whole page for each channel separately, and then you process those colors and produce the output from those separate colors. And the graphics library or the graphics processor must have the ability to handle target surfaces with multiple color channels, not just process color channels. Let's come to patterns and shadings. Patterns have the capability, for example, that they have a different transform, coordinate transform, than the transform that is in the context of when you use the pattern. You can see that here. The background is the page, the yellow background. The square that is around the pattern is slightly rotated to the right. That's the transformation that is used in the current context, in the current content stream where you invoke the pattern. And within the pattern, you see those lines that are transformed lines with a different transformation matrix. And most graphics libraries that I know just know one transformation matrix in their device context. And there are other features of PDF specialities around patterns, such as the step parameter. What's the step parameter? You have the star on the light side, which itself is a little pattern cell, and this star is repeated to fill the figure, the circles and the rectangle there, and the distance between each pattern cell which is repeated is called the step parameter. And if they differ, if the dimensions of this pattern cell and the step parameter differs, you can produce very specific effects with filling figures, which most libraries cannot do, that I know, because they just use the pattern cell itself and they don't have a step parameter. And the big topic is shadings. There are seven shading types in PDF. Most of them are unique to PDF, except for type 2, which is axial shading, and type 3, which is radial shading. Most libraries support those shading types, but the others are not supported. Especially the type 6 and type 7, which are tensor product shadings, and Kunz patch shadings, which are very complicated from the specification point of view. And what most people do, they just render the pattern into a bitmap, and they use that bitmap to fill the figure, but that's not exactly what the specification means. And beside of the performance that is not okay with such a procedure, one must know that shading patterns are, from the concept, knockout transparency groups. If you ever ask you a question what knockout groups are good for, then you know now they are used to handle shading patterns. And here are the type of transparency groups that you can use in PDF. On the left side, you have non-knockout groups. Non-knockout means that you draw a figure such as the gray rectangles or the black circles, and you use a kind of blending mode. Here is alpha blending used, and you see how the circles blend with the background. In an isolated group, you can't see the background, the circles are gray, and in the non-isolated group, you see the background shine through. Now, if you enable knockout groups, then you have the blending not with the previously drawn figure, such as the previously drawn circle. You blend the circle with the backdrop. The backdrop is the initial content of the group. And you see that on the right side, that the only difference between the picture in the upper row and the picture in the lower row is that the background shines through or not. Now let's enlarge the left top picture to see what happens if you use anti-aliasing. Then you see the anti-aliasing is, it covers the shape of the total figure. It does not, you can't see the anti-aliasing between the two circles. And to achieve this, that's the correct result, by the way, you achieve this by separating the shape of a figure. A figure has a shape which is inside 1 and outside 0, and at the edge of the figure you use it to perform the anti-aliasing. And the second thing is opacity, is the amount of color that shines through the figure. And if you separate these two things correctly, then you can implement knockout groups, and only then, oh, that seems to be a font problem. This is a PowerPoint, by the way, not a PDF-A. Okay, what this image should tell you, and does not, is, I go up, is that most graphics processors only support an alpha channel. They don't separate between shape and opacity. But in order to implement such knockout groups, you need to separate shape and opacity. Remember, if you tell, if you think I don't use knockout groups, that's nothing for me. If you draw shading patterns, you need knockout groups. So if you need shading, then you need implicitly knockout groups. Here is a wrap-up of the things that I told you. Just to summarize, let's go to a number of problems that I detected in conjunction with the specification. You see on the left side the Acrobat implementation of the blend modes. On the right side, if you implement the same thing word by the specification, you get a different result. And why is that? In the specification, for example, if you have a CMYK color space, then 0 means no color, and 1 means fully saturated color. But transparency works the opposite. All transparency functions, independent whether they are color space based or not, work like this. 0 is full color and 1 is no color. And I call it additive or subtractive representation of samples. And the transparency is based on additive sample representation. Did you know that? You knew it, but it's not in the specification.
It's not in the specification.
Yeah.
Hey, the specification is clear. It says do color management when necessary.
That's not a color management issue. Sorry, that's not a color management issue. It's a sample representation issue, and it needs to be fixed in the specification. Do you agree, Leonard?
Yeah, we should probably do something about that.
Yeah. Okay. Okay. A second thing is shading Kuhn's patch. You know that picture from the PDF reference. You can draw those kind of shadings so that they fold over each other. And there is a rule in the specification how this needs to be done. Then I asked 2 developers to implement it, 2 different, because it's complicated shading and wanted to get things right. So I get 2 different results. My first thought was one of the developers did it wrong. Then I found out, no, both did it right. The specification is ambiguous. You can do it either way, and it follows the specification, but it produces a different result. So this one has to be fixed too in the specification. And there are lots of other things that I found out during development of the rendering engine. A list of things that need to be fixed in the specification or clarified at least, such how the step parameter in tiling patterns exactly works, and things like that. There is a lot of things that are not within the specification. That helps in reliably implement a rendering engine that produces exactly the same result as one would expect. There are some topics that I didn't cover, such as text rendering we could talk about text rendering days and days, so I decided to leave it out completely. And print production topics such as transfer function, halftones, there are lots of print production topics that are also part of a rendering engine that I left out here. Now, let's go back to the initial question, make or buy. Should I use an open source graphics library to implement the rendering engine? The answer is yes, if you have a very limited set of features in your PDF files. You only have RGB, you don't have complicated transparency, you don't have special paths and things like that. Then you can go that way. Write it from scratch. If you have a lot of money, if you have a lot of time, and you have a high frustration level, go ahead. Here's my conclusion. Using graphic, as I said, a very limited set of PDF features is required, such as business documents, for example. If you have a viewer that displays business documents, very simple, just fonts and perhaps a logo, no transparency, everything is RGB. You have a very limited set of features, then this is certainly a way you can go. But if you are, for example, in specialty printing, which everything needs to really be okay, then you need a professional rendering engine, and you should consider the option to evaluate the third-party product as long it's not of strategic importance to you to have your own rendering engine. That's it. Thank you very much. If you have questions, feel free to ask.